Swayam Prabha. Digital India. Educated India.
Welcome to this 17th lecture, which is on well completion. So, the topics covered in this lecture well completion, followed by well development, followed by well protection, then it moves on to well rehabilitation, and lastly well testing for yield. So, now we will start with the first topic of this lecture, that is on well completion. So, this well completion, it is the process in which basically a permanent nature of the well is established. Whenever a well is dug, so it is we are disturbing the land profile by drilling a well, and then once this land profile is disturbed, so that we get we can harness groundwater, we can extract groundwater. So, then what happens is, so there is a possibility that there is either erosion or undesirable erosion or sedimentation of all different sizes of soil particles. So, it can range from the smallest clay to even boulders, even it may not go up to boulders, but definitely it can go up to gravel or as well. So, therefore, there is a need to maintain this balance, and that is precisely done in this well completion. So, basically, so well completion is the process of ensuring balanced sedimentation stroke erosion of the particles forming the geological strata in which the well is drilled. So, this the word balanced sedimentation or erosion. So, this is very important. So, this is to do that. So, the processes involved in well completion are so the first one is that is placement or cementing of well casing so here this is and stroke or so this is a placement of well screen and so this is placement of gravel packing or simply gravel packing. So, these any or all of these three processes are involved in this well completion. So, now let us briefly discuss what this well casing is or well screens are and what these gravel packings are and how do they help in this well completion process wherein a balanced sedimentation or erosion so that it attains a steady state and so that the geological formations will remain. So, that is ensured. First let us discuss about this that is the well casing. So, here so this so this well casing so basically it is the to maintain so it is a lining to maintain an open hole from ground surface to the aquifer, from the ground surface to the aquifer. So, basically here what is done is some cover is provided so that so this is the opening the open hole from the ground surface because see the thing is unless we ensure a continuous that is supply of groundwater. So, well will not serve its purpose. So, therefore, so this well casing is very important wherein so this the porosity or rather the perforated nature of the ground is maintained. So, through which this infiltration takes place and so this when I talk of infiltration. So, it involves percolation which is generally in the vertically downward direction as well as seepage which is generally in the lateral direction. So, therefore, so this well casing essentially ensures that so the well gets the necessary the groundwater storage into the aquifer. So, through which the well draws its water. And here, so there are this one, that is so this well casing. So this is, here you can say this is types, or so the first one is the surface casings, and followed by so there is a pump chamber casing. So these are all self explanatory. So here the surface casing is at the surface level, and what it does is through the upper strata of unstable or fractured material. So it is installed, and then relatively into a stable and relatively impermeable material. So here, so it serves various purpose, such as it supports unstable material during drilling, reduces loss of drilling fluid, facilitates installation of removal of casing, aiding in placing a sanitary seal, and lastly it serves as a reservoir for a gravel pack. So basically this is surface casings. So here you can say the purposes of surface casings, which are installed at the surface level, are, let me write here, A, so let us say this is 1A, that means 1 refers to surface casing and then A refers to the first purpose. So this is supporting unstable material during drilling, that is during well drilling. And next it is the next purpose is reduction of the drilling fluid loss. So this is also, this purpose is also achieved by surface casings. The third one is, the third purpose is facilitating the installation or removal of other casing. So there may be some other casings, so that is either the installation or removal, so that is facilitated. And fourthly, so it is helping in placing sanitary seal So, this is also one of the important purposes of surface casing. And then lastly, it is serving as a gravel pack reservoir. That means, whenever we need gravel pack, so this surface casing will provide that from its this one from its storage. So, these are the purposes of surface casing. And then, so this is next coming to the pump chamber casing. So, here it consists of all casings above the screen in wells of uniform diameter. So, next is so whereas this surface casing, so they are at the this is at the surface level, whereas pump chamber casing, so these are at the all the casing above the well screen. Having uniform diameter. So, here I am writing here having a uniform dia. So, this is pumped chamber casing. Okay. Whereas surface casing is at the surface level. So, this is regarding the placement of well casing, and many times, so this cementing is also required, because simply placing a well casing is not good enough. So, it has to be held there. So, therefore, for that cementing is required. So, for that we may use a cementing material such as the ordinary Portland cement or any other binding material. So, which will hold in position the well casing. And then, so next we will go to, that is the well screens. So, here in the well screen, so it is basically, it is some kind of a this one perforation that is on the well, it is between the lateral surface of the well, and so through which only a limited this one, that is limited amount of soil particles will be allowed to this one. So, here, so this so well screen, it is a perforated cover placed on the groundwater yielding surfaces or surfaces of a well. So, and here, so this is so depending upon the formation, and also the well casing also differs, and of course, the depending upon the well yield. So, the that is the say for example, the well casing as well as screen. So, the size of the sizes of well casings and screens and well screens the recommended minimum sizes of well casings and well screens as per the USBR, United States Bureau of Reclamation. So, they are as follows. So, they are based on the well yield in meter cube per day, and so nominal pump chamber casing dia, so that is in centimeters, and surface casing dia. So, that is also in centimeters for so this is for A, B, C. So, here this A refers to, that is naturally developed wells, B refers to gravel packed wells, and C refers to I am sorry. So, this is only A and B, and then the nominal screen diameter, nominal pump chamber casing diameter, and here let me also give. So, that is so here let me do it like this: nominal diameter in centimeter of so here this is a for pump chamber casing, and then well screen. So, essentially we have, so this is our first column, that is the well yield in meters. So, the next column is the nominal diameter for pump chamber casing and nominal diameter for well screen, and then followed by, so this is the surface casing, this let me call this A, and then this as B. So, here, so this is well yield. So, there are the various things are there. So, this is less than 270, then 270 to 680, and then 680 to 1900, and then 1900 to 4400, and I will not go beyond this one. Let us, although there are many more are given, so let us say 4400 to 7600, and for this the nominal pump chamber, so this is 15, 20, 25, 30, and then 35 in centimeters. So, that is the nominal diameter for pump chamber casing, and then similarly nominal screen diameter is 5 for a well screen, that is 5, 10, 15, 20, then 25. And so here the surface casing, so the diameter, that is A for naturally developed wells, okay, C is not there, this is A for naturally developed wells. So that is 25, 30, 35, 40, 45. And then similarly, so here it is for gravel packed wells, so this is 45, 50, 55, 60, 65. So this is taken from the US Bureau of Reclamation, and of course the same this 5 centimeter gap, so that goes on. So the next level is, so here I can represent the various sizes of the well yield. So this is well yield, so that is in metric cube per day. Okay, so here let me represent this one. After 7,600, next is 14,000, next is 19,000, next is 27,000. So that means, so from 7,600 to 14,000, so this everything gets increased by 5 centimeters. So it is 40, 45, 50, and then similarly here it will be 30, 35, 40, and then similarly here it is 50, 55, 60, and then similarly here it is 50, 60, 70 only in this case, whereas in this case there is 65, 70, 80, 90. So like that. So these are this one, and now we will move on to, that is so there is also an equation that is given for the so that is optimum entrance velocity of water through a well screen. Water, that means obviously this is groundwater. So this has been so done by, so this has been proposed by Walton, and Walton in the year 1962. So that is, so the hydraulic conductivity in or rather aquifer hydraulic conductivity in meter per day versus the optimum screen entrance, optimum screen entrance velocity for groundwater. So that is in meter per minute. So here, so this is 250, then 250, 200, 160. After every 3 rows, I am going to write a horizontal line 160, 120, 100. Next it is 80, 60, 80, 60, 40, then 20, and then less than 20. So, the optimum screen entrance velocity, so this is 3.7, this is all in meter per minute, 3.4, then 3, 2.7, 2.4, 2.1, 1.8, 1.5, 1.2, 0.9, and then 0.6. And here for this there is a formula that is, let me write the formula here. This is Vs is equal to Q divided by C pi ds, C pi ds Ls multiplied by P. So, this is Vs is the, so this is the optimum screen entrance velocity for groundwater, so which is denoted by Vs, and then Q is obviously it is a discharge, the well discharge, and then the C is the clogging coefficient, and so it is generally 0.5, and then so there is ds is the well screen dia, and then this Ls is the well screen length, and then lastly this P is the percentage open area. Open area in screen. Percentage screen open area. So, basically, so this is the formula. Based on this, so this optimum screen entrance velocity is expressed by this formula, that is Q the well discharge divided by C the clogging coefficient and multiplied by pi multiplied by ds Ls into P, where P is the percentage screen open area. And here, so this is how the optimum entrance velocity, once this optimum entrance velocity is ensured, so then so we can expect that so there will be the well will function better. So, next we will discuss about this gravel packs. So, these gravel packs basically they serve as they consist of gravel, and then they serve as a via media, an intermediate media between the aquifer material as well as the well. So, wherein there is the hydraulic gradient, and so this actually they will reduce the groundwater velocity significantly, and then so let me show you a typical this one. This is a, it is say suppose this is the well, and here so this is the ground level, and here so this is the well shoe. So, this is the shoe, just like our shoe which protects us against this one, and in between so there is a and here so the screen goes on, till the impervious layer. So, here clay or other impervious layer. And here, so this is typically once so here you can say this is the gravel pack. Around so here there is a so this is the well cap. And here you can take this to this one. So, this is the there is one more casing here. Let me show this. And so, let me and so here, so this is the okay. So, this is the shoe, and then this is the gravel. This is the gravel wall or gravel pack. And here this is so here this is a temporary casing. I am sorry. So, this is a temporary casing, and then so here this is a working casing. This is intermediate. This is the working casing, and so the red one. So, this is the protective casing. So, this is the I have just shown this with the red color, and then followed by this black one. So, this is a gravel pipe. So, this is a gravel pipe which is 8 to 10 centimeter. Dia, and then so this is a temporary casing here, which of course I have already shown. So, this is a 15 centimeter or more grouted this one. And then so this is the topsoil, and so this is a typical this is a gravel pack, a typical well with gravel pack. So, this is how the well completion is done, so that well attains a stable configuration, so that there is a balanced erosion and sedimentation. So, next we will go to well development. So, that is the next topic of this lecture. So, essentially, so this well development, it is the process of increasing specific capacity. Increasing well specific capacity, and let us recollect here. So, a specific capacity is the discharge per unit drawdown, that is a specific capacity. And so, additionally, so this is prevent sanding, that is accumulation of sand, comma obtaining maximum economic benefit through the well for its extended service life. So, all these things, firstly it is increasing the well specific capacity, which is, that means increasing the discharge per unit drawdown, preventing the accumulation of sand, because once the sand is accumulated, so then it will the well discharge will reduce, and because and then next is obtaining the maximum economic benefit. So, that means quality water should be quality groundwater should be extracted. So, over an extended service life of the well. So, all these things are involved in well development. So, the processes the common processes employed in well development are: one, pumping; two, it is surging; three is surging with air, and fourth is backwashing. Again this is with air. Then so followed by hydraulic jetting, and use of appropriate chemicals. Hydraulic fracturing, and lastly use of explosives. So, these are some of the processes which ensure that we can increase or if not maintain the initial level of specific capacity, prevent accumulation of sand, as well as obtain quality groundwater for the extended life of a well. And here say some of the typical this one. So, here I would like to bring it to the notice, that is so here this compressed air. So, basically as we all know, so this air wash is very effective in removing the fine clogged particles, and then so therefore we can ensure an increased we can maintain a high level of specific capacity, or we can further increase the specific capacity. And so therefore this so in this case the typically the air jet plays a very important role. So, in this case say suppose this is a well, and here we have so the suppose this is the so this is the well casing. Well casing, and then here there is a below that, so there is a well screen. I suppose this is a, and then so there is also there is an air pipe and this air pipe so this is the fine sand deposited into well. So, this is the air pipe, and here there is a, so typically so this is the air jet, and in this case so this is the discharge. So, water is taken out here, and this air is here, and then so there is a clamp here. So, let me use this So, this is Q, and then so here, so this air is an air jet is let in through the air pump, and then so that what it does is, so it will simply it is blow the fine sand which is deposited, and so this one, so the well is so this is basically a well development through compressed air. And of course, the same thing can also be done by this backwashing through air, and of course, the various kinds of chemicals, or this hydraulic jetting. So, this is say in this hydraulic jetting, say suppose so here say suppose this is the screen material, and so here what is done is, so this is a well development through hydraulic jetting. So, here typically a hydraulic jet. So, what this does is through this hydraulic jet, so this the screen cloggings are removed. In this case, the well is developed, and then so this is also one of the methods of this one. So, we will stop here, and we will continue in the next lecture on this one. Although we had planned to complete this well protection, well rehabilitation, and testing of wells. So, for want of time, so this will be discussing this at the beginning of the next lecture, and move on to the new chapter in the new module in the next lecture. Thank you.